In this tutorial, I will use this example to show you how to solve for missing value in a right angle triangle using the Pythagoras theorem. The Pythagoras theorem can be used to find the missing side when two sides are known and we don't have none of the angles in the right angle triangle is given. So now, this example has a big right angle triangle PQS with only one side known, because QS, we have 5 cm from Q to R. X is unknown, this part is unknown, so we cannot solve for this third part using this triangle PQS. But then again, we have a smaller right angle triangle PQR. PR is 13 cm and QR is 5 cm. So we have two sides known, we can solve for this side. The Pythagoras theorem says that a square plus b square equals to c square, which means that the square of the two sides of a right angle triangle equals to the square of its hypotenuse, which is the longest side. In this case, we have two sides, PQ, one Q, we can say line PQ square plus line QR square, line QR square will be equals to the square of this hypotenuse, that's line PR square. PQ squared is unknown, so we leave it as that. PQ squared will be equals to PR squared. PR squared is 13, so we have 13 squared minus QR squared, which is 5 squared. So this will be 169 minus 25. So we have line PQ squared equals to 169 minus 25. Line PQ squared will be equals to 144. Taking the square root of both sides, our line PQ will be equals to square root of 144, which equals to 12. So line PQ is now 12 centimeter. Now that we know the value of PQ to be 12 centimeter, this bigger right angle triangle can be solved for, because now PQ is 12 centimeter, PS is 15 centimeter. We can solve for the third side, QS. So now, just like we have stated the other way, this is the hypotenuse now in this case, it's 15 centimeter. So we say line PQ squared plus line QR squared will be equals to the square of the hypotenuse, which is line PS squared. So PQ squared is 12 squared plus QS squared. I want to write QS here. QS squared is unknown, so we have that QS squared. Then PS is 15 squared. By collection of like times, QS squared will be equals to 15 squared minus 12 squared, which equals to 15 squared is 225. It's very important for you to know your squares of your perfect square from 1 to at least 15. Then minus 12 squared is 144. So 225 minus 144 would give us 81. So we have line QS squared equals to 81. Taking square root of two sides, line QS will be equals to square root of 81, which equals to 9. So now, from here to here is 9, which means we can label our new triangle as this. The right angle triangle now can be labeled as this. Since QS now is 9 centimeter. So we know that our line QS equals to 9 centimeter, but line QS equals to line QR, that's from here to here, plus line RS, that's from here to here. Now, this is 9 centimeter equals to QR is 5 centimeter plus RS, which in this case is our X. A collection of 9 times, we have line RS equals to 9 centimeter minus 5 centimeter, which will give us 4 centimeter. So therefore, our X in this triangle equals to 4 centimeters. So that's how to use a Pythagoras theorem to solve for missing values in the right angle. You just have to look, no matter how complex the triangle looks like, look at it, look at how you can break it down to smaller parts, solve for each value one step after the other. and you arrived at the perfect answer.